Hi, everybody. I'm going to talk a little bit about software development using GenAI. And I'm going to wear 3 or 4 hats during this conversation. And the goal is to tee up, and we'll have a discussion at the end. Hopefully, this is a small room, we can talk. So I've been at AWS for 17 years now. So I've been involved in a number of evolutions. What was the phrase you used? Remarkable shifts or whatever? Transformative shifts. In 2008, when I joined AWS, I started using EC2 in basically October of 2006, probably 2 months after it got launched. I never worked in tech before. It was big enough that I left my previous life because you knew the world was changing. Jason and I go back to our previous lives in life sciences and stuff like that. So that was one. 2014, I started the containers org at AWS because it became pretty clear that containers are going to change how a lot of us were building and deploying software. And then 2 years ago, everything changed. And it was so clear. I think what happened was all of us, those of you who've been to reInvent, when you come back from reInvent, you don't have the energy to talk to anybody. So we all went back, took a break. But during the holidays, all of us played with ChatGPT. We came back in January and go, we all have new jobs now. I literally did. So I'm going to talk about it from that perspective. What does it mean to start thinking about and get perspective from customers about what they're doing with building software using GenAI? One of the other hats I wear is actually building tools that enable the rest of AWS's and Amazon's developers. And we have a very, very large number of developers. But also within my teams, as we have thought about how we operate and run differently, I think that came up as one of the survey questions. That's something actually we think about all the time. Because we are using the tools that we are building to build the tools that we are building. And it's been an interesting exercise as the tools have gotten better. Because a year and a half ago, they were basically bad. But now they're not. And so that's one. And then the third one is basically the leader of a large software org and part of what does it mean for the future and how we think about it. And I'm looking forward to some of those conversations. This is a Slack message I got actually last week. You can read it. But basically, the fun thing about this was, and I'll talk about AWS products, but these are more general statements. So we have this thing called the QCLI. It's a command line tool. I like the terminal. I mostly still stay in the terminal. And the QCLI is an agent. You talk. It sits in your shell. The shell part of it came from an acquisition we did 2 years ago for a company called Fig.io. So these folks, and it's an open source project, you can go take a look at it. But basically what this person found was they had asked the CLI to do things for them. And it did the same thing on three tasks. And then the agent itself figured out was doing the same thing again and again and ended up writing a Python script to automate the whole process without being asked to. And I get Slack messages like this every day. The world is... And I would not have believed it 6 months ago. In the last few months, this has been I think there have been shifts even in GenAI. ChatGPT felt like a moment. You would argue Claude 3.5 in particular felt like a moment, where your models were starting to do things that, given the right context, given access to the right amount of code base, things like NCP came along to give it steering capabilities. They're now doing things that sound like science fiction, but are actually things that people are doing every day. And the fun part is most people are figuring it out by accident. This person wasn't looking to do this. They just realized he could do this. Now his workflow has changed forever. I get to see this at home. My wife's a software developer. She started using some of these tools some months ago. And she would use them as the auto-completion part of what that survey showed. And now she writes code completely differently. She will let the AI write the code up front, and then she'll spend the next 6 hours refactoring. And just the whole workflow of how she writes software has changed radically and allows her to go tackle things that in languages she may not be really good at. My favorite story about the QCLI was a pull request that we got from another engineer at Amazon about 2 weeks or a few weeks after we launched it, where he submitted a pull request. The QCLI is written in Rust. That engineer speaks zero, didn't know any Rust. He used the QCLI to code it in Rust and submitted a pull request for the CLI. So the world is changing, and it's not just about, I think the part that I drank the Kool-Aid a while ago, but the part that I've come to believe over the last few months is if we still think of AI code assistance as code completion and auto-completion, that world is gone. And I think the biggest difference I've seen inside Amazon is 2 years ago, all the people using these tools were our junior engineers because they could type faster. And our senior engineers were like, I know the code base. I can just type faster than the AI and I make fewer mistakes. But now, with this kind of tooling available, that is starting to change. And I'll talk about that a little bit more. The other part that's happening is everything that I've talked about is very synchronous. You are interacting with an agent. It's giving you feedback in real time. Yeah, sure, you can go have coffee. But I think the other part is going to be these asynchronous agents. What you're seeing here is an example of an agent that we have in GitLab and in GitHub. It's the same agent, but it's asynchronous in some ways. But what it does is you go to a GitHub issue. You want to write documentation. You just create a new issue. You want to refactor something. You write a new issue. And then you assign the issue to the agent. The agent goes ahead and does your pull request for you. And it also does your code reviews for you. It can generate tests. It can generate the documentation. So these are asynchronous things. You are working as part of a team. One way to think about it is every software team that I've ever worked on has a backlog bigger than what they can handle. And you have all these tasks that you'd rather not do because they're boring. Now you can just you have your backlog. You can start assigning backlog items to an AI agent. That's a very simple example of how software teams could operate differently now. That's not even 2 years from now. Your bottleneck is going to be code reviews because right now, if you ask anybody, and if you're in an org where you require 2 code reviews, you have to find the engineers who will do the code review for you, and sometimes that takes time. And if you're generating code at a much faster rate and doing much more pull requests, your code reviews are going to become the bottleneck. So how do you think about code reviews? Should your check-ins be smaller? Because the larger your check-in, the less likely somebody is going to pick it up. Those are the kind of discussions we are having as a development org. Like, because we are using these tools to submit code, how should we handle code reviews? How many code reviews should we do? Should we do first code review AI, second code review human? And I think these are the kind of fundamental organizational questions that all of us who are writing software and running software teams need to think about. So, kind of where are we headed? Will you type code anymore? I asked one of my teams last November-ish, it's like, if you were in a world where as a human you were never typing, you were actually not writing the code, you were just typing natural language, and the code was just an artifact, what would the interfaces that you build look like? Because you don't need you don't need necessarily an editor that's telling you what the next thing should be, whether you have the right syntax. You can look at it. It's almost a read-only system. And a good example of this is a customer that is an airline that most of you have probably flown on. And they have added features to their website where nobody typed a single line of code using the CLI. Every line of code was natural language prompted. And these are in production right now. Now it's a website. It's not back-end code. It's not the code running the airline. We'll get there someday. Not yet. Don't do it. But it's a sign of the times of what it means, which is why one of the most significant features we released this year was adding natural language support in about 250 languages or whatever to Q. Because when you're writing a programming language, you learn the programming language. But if you're writing in, I think the example we used was in Telugu, which I don't speak. It's like a lot of squiggles. Or Thai or whatever. Then it matters. Like your code comments automatically happen in that language, in the language you're prompting it. And all of those things, that was actually one of the most important things we did, because when you're writing natural language, people want it in their language, not Python or Ruby or pick your language here. So I think that's a good question to ask, is how are you going to, how will you be writing, is code going to be code itself? Will you be typing it? Or is it something you look at just to verify because you understand it? And you know the AI systems aren't perfect, you still need to inspect. So that's one big part. Those of you who've been at Amazon may know what this means. We have a principal engineering tenet called illuminate and clarify. So principal engineers illuminate and clarify problems. This goes back to who is benefiting. When you are just doing auto-completion, It was just a question of, can I type faster? Can I get things done? Or if you're using cursor, you just hit tab, tab all the time. Works really well. But if you're a senior engineer, principal engineer, you are trying to solve problems. You are trying to give the AI instructions on what you want it to get done. You're giving it goals. You're giving it tasks. You're giving it a set of tools. You're telling it, here are the MCP servers you're allowed to use and how I want you to think about using them. You're crafting your prompts a certain way. The way I like to frame it is, only you as an engineer know that you wanted a duck and not a platypus. But if you say you want a bill and webbed feet, the AI doesn't know. It might give you one or the other. So there's this, and I think that's why when you're getting into this frame of writing software, our senior engineers tend to be more into it than even the junior engineers, because they're not thinking of code. They're thinking of the problem and how to break it up into its smaller tasks that help them get where they need to. So I think if you're asking about what are the skill sets that people need to develop, learning the next programming language may or may not be the most interesting one, but thinking through a software problem, how do you break it into subtasks? What are the ways you think about telling an AI system where you want to get to? Like what bill and web feet may not be enough. You may have to also tell it, I want feathers. If you want the duck, super important. The other part that I often get this from customers that I speak to is like, oh, can we hire people who don't know how to write code that well? Maybe. There's lots of software that helps you do that. But I actually think in the kind of code-first systems that I'm talking about, where code is the artifact, actually having people who understand the code, or at least some people, it actually makes them more effective. The people I see most effective using these systems are the ones who are really, really good. I vibe code, somebody said vibe coding earlier, all the time. Like I built an app I write apps for my kid. Solar system simulator. This morning I actually made an app that converts a molecule into a 3D structural representation. I'm trying to teach him chemistry. All my degrees are in chemistry. And I can only tell, because it's written in a language, I don't know JavaScript Node much. But I can only tell that it's working because of the output. The output looks good, the code must be okay, and I look at it, the structure looks fine, but I can't really tell. And this is a simple program. But somebody who knows what they're doing will do a much better job. So I think one of the things we should be thinking about, and we actively think about, is how do we make the practitioners, the people who know what they're doing, I guess a lot of folks in this room, more effective. So this might mean giving them the tools. It might mean focusing actually on things like the operation, not even the code side, but the outer loop, the operational side, the incident response. How do you catch their signals and feed them back into your software development cycles? Those are problems that have not been solved. And your approach towards building software will change. Like the example I gave, where you write things up front and edit afterwards. But those are still with more interactive agents. But when your agents are more asynchronous, where you can tell it to go do its thing, and you're not going for coffee, but for lunch. Or maybe you're taking a nap and coming back in the morning. How do you think about software? It is changing right now because of how fast things have moved in the last few months. And how you set up your teams may change. Right now it isn't. Nobody, as far as I know, maybe some of you have. I don't know anyone who's actually changed the structure of their software development team. They've changed their practices, how do they do code reviews, et cetera. But I don't think anybody's built a software team differently. But in a team where you can start assigning backlog items to an AI system, when you have that opportunity, how would you think about it differently? So anyway, over the last 2 years, whether it's because of mistakes we made, seeing customers in action, there's some lessons learned. I like using this swimming pool complex metaphor, which is 2 years ago, if you went and talked to somebody, they were likely in the children's pool, the one that's shallow throughout with their life preservers on, because they were too scared to go into any of the regular pools. They didn't trust the AI for good reasons, hallucinated like crazy, very confidently, still does, but the way of managing context and all was very hard. Your context windows were really small. But over time, as the foundation models got better, customers' comfort level, they also learned how to work with them. Humans are pretty fallible. You ask 5 people the same question, which is not a 1 + 1 = 2 question. They'll probably get 4 answers, and AI is not that different. Humans are also stochastic, they're not deterministic. People learned how to work with stochastic systems. And so they stepped into the regular pool. Many of them started going from the swimming shallow end to the deep end. I would say today, most of the customers I talk to are either well on their way or already there. And there's some who are like YOLO, big Olympic pool, just dive in, we'll see what happens. Some of my teams are probably in that category, kind of had to be. But we met some pretty big customers, like big companies, who are in that. I mean, I don't know if any from Intuit is in this room. To me, whenever I talk to them, it's like, you're brave. They were brave 2 years ago. The thing that has helped within Amazon and within the customers I speak to who've been successful is allowing people to be curious. So there are a lot of CIOs who will come and ask me, what are the things I need to do to protect myself? And the answer I give is, you're asking the wrong question. The question you should be asking is, how do I let every builder in this company have access to these tools and do something, and then make sure nothing bad can happen? And that's what we did inside Amazon. Like, everybody can access, and there's a set of tools, the whole company has access to them. There are some very successful products inside the company, some of which I made them externally, that were not built by a team, that were not written by a working backwards document. It was some engineer deciding to go do things. One of the examples on my own team is there was a guy who wanted to teach himself prompt engineering. He built an app, and he was smart. He got AppSec permission on what can be uploaded to it early. He built a magic builder where you gave it a prompt and it converted into an app. But the fun part was it had widgets. You could go into the widget, change the prompt, look at the temperatures. He was trying to see how the AI, and you could even change the model per widget. It got so popular, next thing you knew, 100,000 people in the company were using it. And it had a share, it was also viral. You could share your app with the next person. And my favorite example of an app that was built using that system was something built by 3 people in our data centers who manage the HVAC system. How many of you have tried to decode error 433 in your air conditioning? Now imagine it in a data center. They took all their documentation, put it in there, built an app that says, here's my error code. It would give them the doc, figure it out, and give them the solution for it. No engineering team is going to build that app for them. Nobody has time. Nobody's going to maintain that app for them. But here you go. And all because one engineer wanted to teach himself prompt engineering. And I've seen many examples of that everywhere. Most of you are in smaller companies, it's not probably a problem. But on a larger company, it's amazing how big a deal this is. If you tell your folks, you must use AI, they'll probably say, get lost, especially software engineers. If you let them figure it out on their own and then support them when they need to, you're going to be successful. It requires a mix. The best organizations I've seen that are successful are the ones where the engineers are really bought in, especially some of the senior engineers, and then their managers are like, okay, how do I make sure you can be successful while making sure we all don't get fired? And that works pretty well. That's all I had from a talking perspective. I'd love to take questions, and if I have time, I don't know how much time I have, but fire away. Please.
Feels like there's maybe properties of programming languages that would be better, whether because they're simpler, there's fewer footnotes or whatever. How do you see sort of the evolution of programming languages in this world?
Yeah, it's actually a good question. I think part of it is, the classic one is, I have a bunch of COBOL lying around, I want to convert it to Java so that people in my company can actually understand it because all the people in your COBOL have retired. So those are obvious ones. It's more, there are things that you today are paying some consultant a lot of money for and doing it. That's fine. But I think where it's meaningfully useful is, let's take a lot of backend systems which you want to write in Rust because Rust is type safe, and they're not written in Rust, but you don't have enough Rust programmers. In fact, we actually, for the CLI, it's all written in Rust, and the manager of that team comes and says, we need to hire a bunch of Rust engineers. I'm like, you could spend a bunch of time looking for Rust engineers, and sure, go ahead. But you could use your own tool to start helping your non-Rust engineers write Rust. Now, these are professional software developers. They understand the basics of software development. Most of them know C. I'm sure they can figure out whether the Rust code works for them, and that's what we ended up doing. We are writing code in Rust in a team where only about a third of the engineers actually know how to write Rust. They do all the code reviews. But it's allowed that team to ship. Like somebody was saying, ship every 2 weeks, we ship every week. That's the try. Can we use AI to ship every week? But that's a simple example. I think what will be more interesting is over time, if your language becomes more assembly-ish, like if you think about that shift towards when assembly went away, and it's just a read-only artifact that you read to make sure it's okay, it'll be interesting to see how that will. I don't know. Like, I don't know what it'll look like. The way I've seen value is bringing people on board and writing in code that in a language they may not know, but your team wants to write code in. That works. Rust is where I've seen it be super successful across the company. Well, they do that without, if you don't tell them what language to do, they happily choose the language. Like if I write in something, 90% of the time it'll pick Python or Node. Like it'll never, I've almost never seen an unprompted agent pick a language, especially if you're starting clean and giving it a simple example, not pick Python or Node, for me. Yeah.
Is that biased?
I think it's partly biased. Now, here's where I think the recent advances in like steering and ability to write these, like you can, for the CLI, you can write a little markdown file, which almost explains, you can put your, like, this is how I like to write software. Now, the fun part will come when reinforcement learning becomes easier and cheaper, because now what you get is, you're a team, you like writing software a certain way. How does a new software engineer learn? Like they watch you, they go do things. If you have a reinforcement learning loop somewhere that's learning from your team, you're learning your behavior, now there you're getting, in theory, it should learn. Today you have to give it explicit signals. At some point it'll become implicit.
Can you talk a little bit about security? There's like people manufacturing patches that match, malicious patches that match hallucinations that go up.
Yeah.
So you can then pull them down. What should an organization do about putting some guardrails?
Yeah, so there's, at least in Amazon, we have 2 or 3 approaches to it. Different companies do it differently. One, actually, code reviews are more important than ever. Anyone, all of you, like when you have a bunch of college hires, you're probably still doing code reviews. So finding code, like people get lazy when they do code reviews. Having good code reviewers is very, very important. There you may want to have some deterministic rule-based systems in addition to having AI-based systems in there. So that's one part. Like take the practices that you have today to make sure there's no unsafe code. There's a lot of tools that will help you also there. At AWS anyway, the second thing we're looking at is automated reasoning, because that is verifiable. So for example, there are pieces of Q today where for factual data, we actually run AR solvers at the back to make sure that as validators, like don't tell me what the price of an EC2 instance is randomly, verify it, you have a mathematical model for it. So those are expensive. Some people can afford to do them, but that's the other area. If you're a bank and you're building an app that does ACH clearing, you probably want to build a model for what that looks like to make sure it always gets verified. Like that's what's going to happen. You will get, Google released this thing, the DeepMind folks yesterday called Alpha or something or the other. That's basically an automated reasoning solver for mathematical algorithmic checking. Same idea. You will use those, but you don't have to go that fancy. Good code reviews, good practices are going to help. Defense in depth helps. Like assume things will go bad and plan accordingly. But that could happen in any software org. The challenge now is the magnitude at which can happen because you can do it much faster. Yes, I can imagine that. And any like your sonotypes and whatever tools you're using for static analysis, make sure you're using them. They help a lot. I'm done. Alrighty. Thank you very much. And